September 2nd, 1942, 1847 hours. Ramenskoye Airfield, outside Moscow. The twin engines of a TB-3 thunder at full throttle, propellers biting into the cooling evening air. Mechanics scatter from the runway edge. A steel tow cable snaps tight with violent jolt. Behind the bomber, something armored and impossible lurches forward. Tracks grind against packed earth. Suspension shrieks. Dust erupts into the fading light. A tank is accelerating down the runway. Inside the turretless hull of the modified T-60, Senior Lieutenant Sergei Anakin braces his shoulders against the steel interior. His padded flight helmet presses tight against his temples. Gauges rattle. The engine growls at maximum revolutions. Above him, wooden biplane wings reinforced with steel strut strain against the building airflow. Canvas fabric ripples and snaps like gunfire. 80 kilometers per hour. 90. The TB-3's Formiculan engines howl in protest. The bomber was designed in another era, its corrugated skin and fixed landing gear relics of early Soviet aviation. Now it drags 5.8 tons of armored vehicle behind it. The tow line screams under tension, vibrating like a drawn violin string. The tank begins to feel lighter. Then, impossibly, the tracks leave the ground. The Antonov A-40 rises behind its tug. Awkward yet airborne, wobbling like a stubborn kite. Ground crew stare upward in stunned silence. No applause. No celebration. They understand how narrow the margins are. In the cockpit of the TB-3, the flight engineer watches the temperature needles climb. Oil pressure rises into the red band. Airspeed drops despite full power. The aircraft commander grips the control column harder, jaw set. The bomber's nose rides high, engine straining to maintain shallow altitude. The drag is overwhelming. Wind batters the tank's slab-sided hull. The T-60's 20mm SHVK cannon points forward into empty sky, absurdly prepared for a battle it cannot fight. The DT machine gun chatters against its mount from vibration alone. Anakin grips the improvised control yoke bolted into the fighting compartment. Every tremor travels through the airframe into his spine. For a fleeting moment, it works. The A-40 stabilizes. Glide angle steady. Forests slide beneath them in dark green waves. Evening light glints along the wing struts. The tank is flying, but inside the TB-3, warning lights pulse. Cylinder head temperatures edge toward catastrophic. The crew exchanges sharp glances. They cannot sustain this. The idea had been born of desperation. German panzer divisions were slicing through Soviet lines, isolating armored units and overrunning supply depots. Paratroopers could deploy behind enemy positions. Infantry could land by transport aircraft. But tanks were chained to terrain. Without armor, airborne troops were exposed. Unless armor could fly. Aircraft designer Oleg Antonov proposed detachable wings and a twin-boom tail fitted to a light T-60 chassis. Tow it aloft. Release near contested ground. Glide in silently. Land. Detach wings. Engage immediately. On paper, it solved everything. In the sky, it threatens disaster. The TB-3 shudders violently. One engine sputters as mixture leans under strain. The commander transmits through crackling radio. Engine temperatures critical. They must reduce load. Anakin hears the order to prepare for release. His throat tightens. Below, the terrain offers no proper runway. Only rough pasture broken by brush and shallow ditches. The tow cable detaches. Silence crashes over him. The roar of the bomber fades ahead. Now he is alone with gravity. The A-40 dips sharply before settling into glide. Anakin adjusts the control surfaces carefully. He understands glider dynamics, angle of attack, the knife edge between lift and stall. But this is not spruce and fabric alone. It is steel armor, ammunition racks, and a 70-horsepower engine bolted beneath him. The ground approaches faster than expected. Airspeed bleeds away. The wings flex under load. A strut creaks ominously. Commit. He pulls gently, attempting a flare. Authority is limited. The tank slams into the field with crushing force. Suspension compresses to its limits. One wingtip strikes dirt, showering debris. The tail assembly shudders but remains intact. Dust engulfs everything. For 1 suspended second, there is no movement. Then the GAZ-202 engine coughs and catches. Anakin releases the wing attachment bolts. Ground crew will later recover the shattered assembly from the field. He turns the tank in a wide arc and drives back toward the airfield under its own power, as though returning from routine maneuver. Behind him, the TB-3 limps through the sky, engines overheated, crew shaken. Another few minutes of towing might have forced an emergency landing. The experiment proved flight was possible. It also proved the margin for survival was razor thin. If a bomber nearly destroyed itself hauling one light tank in calm conditions over friendly ground, what would happen over enemy lines? Under fire, with combat fuel loads and winter winds? The concept had lifted from the earth, but whether it could survive war was another matter entirely. Autumn 1942. Design Bureau, Moscow Aviation Institute. Drafting lamps burn late into the night. Frost creeps along the inside of the windows. The city outside is blacked out, but inside the bureau, pencils scratch across linen-backed schematics with relentless urgency. The Tank Wings project is no longer a spectacle on a runway. It is a calculation problem, a brutal one. Engineers crowd around weight tables pinned to corkboards. The T-60 light tank, already the smallest armored vehicle in frontline Red Army service, must be stripped to the bone, ammunition reduced, fuel minimized, even the headlights removed. Every kilogram matters. 5,800 kilograms is the baseline. Too heavy. They discuss replacing steel fittings with lighter alloys. They debate wing loading ratios. Lift coefficients are recalculated again and again. The biplane configuration was chosen for structural rigidity at low speeds, but it creates drag like a brick wall. And drag is the enemy. The TB-3 tow aircraft is obsolete by 1942 standards. Slow, underpowered, built in the early 1930s. Yet it is one of the few bombers available in sufficient numbers that can operate from rough airstrips and tow gliders. More modern aircraft like the Petlyakov P-8 are needed elsewhere. No one is willing to sacrifice strategic bombers for experimental tanks. So the engineers must make the tank lighter. They sketch detachable wooden wing panels with fabric covering. Steel bracing wires crisscross the design like a spider's web. The twin boom tail is positioned to clear the tank's turret ring and exhaust vents. Control cables must route through improvised channels inside the hull. Inside workshops, carpenters work beside armorers. Sawdust settles on steel plating. Mechanics bolt mounting brackets directly into the tank chassis. Nothing about this feels elegant. It feels urgent. The Red Army in 1942 is fighting for survival. Stalingrad is becoming a furnace. German army group south presses toward the Volga. Every innovation is measured against a single question. Will this help hold the line? Antonov believes it might. He walks through the hangar where the prototype rests, wings folded like a resting insect. The T-60 beneath them appears small, almost fragile. Its 20mm SHVK cannon, effective against infantry and light vehicles, is not meant to duel with Panzer III or IV tanks. The A-40 was never intended to spearhead assaults. It was meant to reinforce paratroopers, to give airborne units a mobile gun platform immediately upon landing, a flying support weapon. But physics does not care about battlefield theory. Test data from the September flight sits on the table. The TB-3's engines operated beyond recommended temperature thresholds within minutes. Climb rate nearly vanished. Airspeed barely exceeded stall margins. Any crosswind would have made the tow unstable. The numbers are unforgiving. Engineers propose using a more powerful tug aircraft. There are none available. They consider removing the tank's turret entirely to reduce weight and drag. That would defeat its combat role. One suggestion gains traction. Land close to the front line so the tow duration is shorter. But that requires forward airfields within range of German artillery. The risk multiplies. Anakin returns to the bureau to debrief. He described the glide characteristics as surprisingly manageable once released. Stable, predictable. The landing, however, required perfect conditions. A rougher field or stronger wind might have overturned the tank. And then there is combat reality. Imagine towing the 40 at night. Engine straining, navigation lights off. German radar stations along the front detect the lumbering bomber. A Messerschmitt Bf 109 climbs to intercept. The TB-3 cannot maneuver aggressively without destabilizing the glider. One burst of 20 mm cannon fire into the tank's wooden wings would shred the assembly instantly. The tank would fall like a stone. Still, the concept refuses to die easily. Soviet doctrine values audacity. Airborne operations have already proven their worth in limited engagements. If a handful of flying tanks could be delivered intact behind German lines, bridges could be seized, rail junctions disrupted. Antonov studies the structural drawings again. He calculates stall speeds. With reduced weight, perhaps the glide ratio could improve marginally. Perhaps a winter deployment, when colder air increases lift, might help. Perhaps. But production realities intrude. Factories are relocating east beyond the Urals to escape German advance. Materials are scarce. Skilled labor is exhausted. The T-60 itself is already being phased out in favor of more capable designs like the T-70. Time is running out for the idea. In a final review meeting, a senior officer from the Red Army Air Forces listens without expression as engineers present their findings. The concept is feasible in principle. Operationally, it is hazardous. Logistically, it is impractical. He folds the report closed. The Soviet Union needs tanks in factories, not in the sky. The A-40 will not proceed beyond prototype testing. In the hangar, the wing tank waits under dim lights, canvas skin slightly sagging in the cold. It has flown once. It has proven a point. But war is not won by proving points. It is won by surviving reality. And reality, in 1942, has no tolerance for flying tanks. Winter 1942. Moscow. Snow presses against the windows of the design bureau like a silent audience. The A-40 project is officially shelved. Its prototype parked in shadow, but the idea lingers in the minds of men who cannot afford to stop imagining solutions. War has a way of resurrecting desperate concepts. Reports from the front arrive daily. German armored spearheads continue to exploit mobility and surprise. Soviet airborne brigades perform raids, sometimes brilliantly, sometimes tragically. Again and again, commanders note the same limitation. Paratroopers land light. They fight light, and when German armor counterattacks, they have little that can answer it. The flying tank had promised to change that equation. In strategic meetings, the phrase is rarely spoken aloud. Instead, officers refer obliquely to armored airborne reinforcement. They discuss glider-borne artillery, light anti-tank guns, motorcycles. The Red Army studies German DFS-230 assault gliders used in operations such as a seizure of Ebony Mail in 1940. They analyze Allied developments with Horsa and Waco gliders. The world is experimenting with air-delivered ground power. The Soviets simply try to push it further. Antonov himself moves on to other projects, but he defends the principle when questioned. The A-40 was not folly, he argues. It was constrained by available towing power. With a stronger aircraft, with better engines, the concept might mature. But stronger aircraft are consumed by strategic necessity. Long-range bombers strike rail hubs. Fighters defend Moscow skies. Every machine has a purpose measured against survival. The tank wings prototype remains intact for a time, a skeletal reminder of ambition. Engineers occasionally revisit its frame, running hands along the wooden spars. They consider theoretical improvements. Monoplane wings instead of biplane. Reduced surface area. Better streamlining of the tank's hull to minimize drag. The calculations improve slightly. Not enough. Meanwhile, the T-60 itself reveals limitations on the battlefield. Its 20 mm cannon struggles against heavier German armor. Protection is thin. Crews rely on mobility and numbers rather than brute force. By early 1943, production shifts increasingly toward the more capable T-70. The window for a light-flying tank narrows further. Yet the story of the single flight spreads quietly through aviation circles. Mechanics tell it over cigarettes. Pilots repeat it with a mixture of admiration and disbelief. A tank that flew, even once, You could imagine how it must have felt to see it rising behind the TB-3, tracks dangling above treetops. The image refuses to fade. Soviet doctrine evolves toward massive mechanized offensives supported by artillery and close air support from aircraft like the Ilyushin IL-2 Sturmovik. The IL-2 becomes known as a flying tank for its armored cockpit and ground attack role. It delivers rockets and cannon fired directly onto German formations. In a sense, the IL-2 achieves what the A-40 sought in a different form, armor and air combined, not by lifting a tank into the sky, but by building the sky into an aircraft. Practicality triumphs over spectacle. Still, the A-40 remains a testament to a specific moment in 1942 when outcomes were uncertain and boldness seemed the only currency available. The Soviet Union had endured catastrophic losses in 1941. Entire armies encircled, millions captured, industry uprooted and moved east. Innovation became both shield and sword. Desperation breeds invention. The flying tank was born from that furnace. Years later, historians would debate its feasibility. Some call it curiosity. Others see it as evidence of creative resilience. In truth, it was neither miracle nor madness. It was an experiment shaped by context. Could it have worked with more powerful towing aircraft? Perhaps marginally. Could it have survived contested airspace? Unlikely. The vulnerability during tow was extreme. A single fighter interception could destroy both tug and glider. And yet, the prototype flew. That fact matters. It demonstrated structural ingenuity. It validated glide control from a heavily armored chassis. It proved that even a machine built to crawl across mud could briefly claim the sky. In war, symbolism has power. The A-40 symbolized refusal to accept limitations. But wars are not decided by symbols alone. They are decided by production lines, logistics, fuel reserves, and attrition. The Soviet advantage would ultimately lie in industrial scale, in thousands of T-34 medium tanks rolling off assembly lines, not in a handful of experimental gliders. The prototype is eventually dismantled, wings removed, components repurposed, the tank returned to ordinary configuration or scrapped. No squadron of airborne armor ever forms. No gliding assault reshapes the Eastern Front. Yet for one evening over Ramenskoye, gravity was challenged. A tank flew, and in that fleeting moment, the boundary between ground and sky blurred, revealing both the brilliance and the limits of engineering under fire. The dream did not survive the war's arithmetic, but the audacity of it still echoes. Spring 1943. Kuban Bridgehead. The air above the Eastern Front vibrates with engine noise and artillery thunder. Soviet and German forces clash in one of the largest sustained air battles of the war. Fighters spiral overhead. Ground troops dig into mud soaked with fuel and blood. In this chaos, imagine a different sky. Imagine a formation of TB. 3 bombers lumbering toward the front at dusk, each towing a winged T-60 beneath fading light. Engines strained but holding. Tow lines taut. Crews silent. It never happened. But the possibility haunted planners long after the prototype's single flight. The concept was simple in theory. Deliver armored support directly to isolated airborne units or partisan forces operating behind enemy lines. Instead of waiting days for ground relief, a gliding tank could land within minutes of drop zones. It could provide mobile firepower against machine gun nests, light vehicles, even fortified positions. Speed, shock, reinforcement from above. Yet the battlefield of 1943 makes clear why the project stalled. German air superiority in contested sectors meant any slow-moving tow aircraft would face interception. The Luftwaffe's Bf-109s and Fw-190s thrived on vulnerable targets. A TB-3 hauling a tank would be a floating beacon. One burst from a 20mm MG-151 cannon into the wooden wings of an A-40, and the experiment would end in flame. Even without enemy fighters, weather posed lethal risk. Crosswinds could induce oscillation in the tow line. Turbulence might cause structural stress beyond tolerances. Soviet forward airstrips were often little more than flattened fields scarred by shell craters. Landing a glider tank intact required near-ideal conditions. War rarely offers ideal conditions. Logistics also undermine the dream. Preparing a single A-40 for flight required specialized assembly crews, reinforced attachment points, careful weight balancing. Each tow sortie would consume fuel desperately needed elsewhere, and after landing, the detached wing assemblies would be abandoned, impractical to recover under combat pressure. A weapon used once and discarded. Contrast this with the emerging doctrine of deep battle. Soviet commanders increasingly relied on mass artillery barges, followed by coordinated armored thrusts using T-34 and KV tanks. Air support from IL, 2 Sturmovik-strafed and rocketed German positions. Mobility came not from isolated airborne gambles, but from overwhelming ground momentum. Scale defeated novelty. Still, there were moments when airborne reinforcement could have shifted tactical outcomes. Partisan operations in Belarus and Ukraine sometimes operated with minimal heavy support. A glider-delivered tank might have strengthened a bridge seizure or disrupted a rail junction long enough to matter. But such scenarios required perfect alignment of factors, uncontested airspace, suitable landing zones, immediate operational necessity, rare combinations. The Red Army chose reliability. By mid-1943, after the Battle of Kursk, the strategic initiative shifted decisively towards Soviet forces. Industrial output surged beyond German capacity. Thousands of T-34s rolled from factories relocated east of the Urals. Quantity became a strategic weapon. In that environment, the A-40 appeared less a solution and more a footnote. Yet engineering ambition during wartime should not be measured solely by adoption. The flying tank represented a willingness to challenge assumptions about what armored warfare could be. It forced planners to confront the interplay between lift, drag, armor mass, and combat viability. It asked a bold question. Can machine built for trenches and forests briefly command the sky? The answer was yes, but only briefly. The tow nearly destroyed its carrier. The landing demanded precision beyond battlefield tolerance, and the strategic payoff remained speculative. So the project faded, not with ridicule, but with quiet acknowledgement that courage and design must answer practicality in war. In aviation museums decades later, photographs of the A-40 circulate among historians and enthusiasts. The image is surreal, a tank fitted with wings like a mechanical insect. It provokes smiles, disbelief, admiration. What it truly reflects is the atmosphere of 1942, when survival outweighed orthodoxy, when engineers and soldiers alike were permitted, even encouraged, to imagine the improbable, because sometimes the improbable becomes essential. The A-40 did not. But its single flight remains a reminder that innovation often walks the edge between brilliance and impossibility. And in that narrow space, history occasionally lifts off the ground. September 2nd, 1942, did not belong only to engineers and generals. It belonged to crews, to mechanics with grease under their nails, to a pilot in a bomber cockpit, watching temperature gauges climb toward disaster, to a man inside a steel hull who felt the earth fall away beneath his tracks. Senior Lieutenant Sergei Anakin was not chosen at random. He was a trained test pilot, experienced with gliders, disciplined under pressure. He understood that the A-40 was not a stunt. It was data in motion. His task was not heroics. It was survival and observation. Inside the modified T-60, space was cramped even by tank standards. The turret had been altered to accommodate flight controls. Linkages ran awkwardly along the interior. The familiar smell of oil and metal mixed with canvas and fresh-cut wood from the wing assembly above. When the tow began, vibration was constant. The suspension, designed for rough terrain, transmitted every shudder into the hull. Anakin later described the initial roll as surprisingly stable once speed increased. The wings carried weight efficiently at moderate velocity, but during climb, he sensed strain through the control surfaces. The bomber crew felt it too. The Tupolev TB-3 was already outdated, for engine provided redundancy, but not comfort. At towing power, each Mikulin engine ran near operational limits. Cooling systems struggled. The aircraft commander had to maintain shallow ascent to avoid exceeding stress tolerances. Every additional meter of altitude demanded more from engines already at their ceiling. The flight engineer monitored gauges with clinical focus. oil temperature, cylinder head temperature, fuel flow. Slight fluctuations became potential catastrophe. If one engine failed under full tow load, asymmetric thrust could yaw the bomber violently. The glider tank behind might swing unpredictably. Two machines, bound together by a single cable. The risk was shared. Ground crew understood this before takeoff. They tightened bolts repeatedly, checked bracing wires, inspected attachment points. Some believed the idea audacious. Others muttered that it bordered on madness. But no one refused their assignment. The Soviet Union in 1942 did not offer such luxury. After release, Anakin's isolation was immediate. The absence of tow tension altered handling characteristics instantly. He had seconds to stabilize. The glide was manageable, but heavy. The tank did not float like a sailplane. It descended with purpose. Landing demanded composure. The T-60 suspension absorbed impact designed for shell-torn earth, not runway precision. That durability likely saved him. A lighter glider might have splintered under similar force. When he drove back toward the airfield after detaching the wings, witnesses later recalled a surreal sight, a tank rolling calmly across open ground, having just descended from the sky. No fanfare, no speeches, simply machinery returning to base. For the bomber crew, relief came only after touchdown. Engines cooled slowly. Maintenance teams examined them for stress fractures and overheating damage. The margin had been thin, too thin for combat repetition. War compresses decisions. Men who participated in the test understood that its future would depend not on imagination, but on feasibility. They had provided proof of concept. Whether leadership pursued it further was beyond their authority. In personal recollections years later, the flight was remembered without exaggeration. It was described as experimental, difficult, improbable, not a triumph, not a failure, a moment, and yet moments matter. Because inside that steel hull, during those minutes of flight, Anakin represented more than a pilot. He represented the willingness of individuals to inhabit ideas larger than themselves, to sit inside uncertainty, to trust calculations drawn on cold drafting tables. The A-40 did not enter production. No regiment of flying tanks ever formed. But the courage of those who tested it remains inseparable from its legacy. Innovation is often remembered as blueprint and machinery, but it is lived by people, men who tighten bolts in freezing hangars, pilots who monitor gauges edging toward red, engineers who accept that their designs may never see combat, yet build them anyway. The flying tank flew once because a handful of individuals agreed to attempt it, and for a brief stretch of sky over Ramenskoye, steel, canvas, and human resolve moved together against gravity. A tank is designed for traction, not lift. Its geometry favors low center gravity, thick frontal armor, compact mass. Every line of the T-60 was drawn to survive shellfire and rough terrain. Nothing about it suggested flight. To make it airborne required confronting physics without sentiment. Lift depends on surface area and airspeed. The A-40's biplane wings provided increased lifting surface while maintaining structural strength through interplane struts and tension wires. The configuration allowed relatively low takeoff speeds compared to a monoplane of similar span. But the trade-off was drag, immense drag. The tank's blunt frontal profile compounded the problem. Unlike streamlined gliders carved from spruce and canvas, the T-60 presented a near-vertical armor plate to oncoming airflow. Engineers calculated drag coefficients and realized the tow aircraft would bear the cost. And it did. The TB-3's engines were rated for specific operational envelopes. At full towing power, cooling margins narrowed dangerously. Sustained high manifold pressure increased thermal stress. Any prolonged climb risked overheating. The glider tank effectively turned the bomber into a struggling draft animal pulling weight through air instead of mud. Wing loading also posed limits. With approximately 5.8 tons distributed across its wing surface, the A-40 required careful balance. Too steep an angle of attack would induce stall. Too shallow and descent rate would accelerate. Glide ratio remained modest. This was no soaring sailplane. Release timing became critical. Detach too high and the TB 3 might fail before separation, release too low, and the tank would have insufficient distance to stabilize before landing. In combat conditions with anti-aircraft fire or crosswinds, precision would degrade rapidly. Structural integrity added further constraints. The wing attachment points were bolted directly into the tank's chassis. Armor plate is rigid but not designed for aerodynamic flex. Stress concentrations risk fatigue fractures. Engineers reinforce key joints. Yet every kilogram of reinforcement added weight, worsening tow performance. A delicate compromise emerged. Strong enough to survive one controlled flight. Marginal under-repetition. Consider also the human factor. Piloting a glider requires anticipation of airflow shifts, thermals, and sink rates. Piloting a tank modified into a glider introduces inertia unfamiliar to conventional aircraft. Control response is slower. Corrections must be deliberate. Over-control risks oscillation. Anakin managed because he was trained and because conditions were calm. Replace calm with gusting wind or night visibility, and control difficulty multiplies. Now imagine enemy interference. A fighter pass could shred fabric surfaces instantly. Even small caliber rounds might compromise structural bracing wires. Unlike armored fuselages of attack aircraft, the A-40's lifting surfaces were vulnerable by necessity. The paradox becomes clear. To make the tank fly, it had to shed the very protection that defined it. Wings could not be armored without becoming too heavy to lift. Protection ended where flight began. This contradiction limited scalability. Some have speculated that more powerful tow aircraft, perhaps with engines exceeding 1,000 horsepower each, could have improved feasibility. In theory, yes. Increased thrust will reduce climb strain and expand operational envelope. But such aircraft were scarce and prioritized for bombing, reconnaissance, or transport. Diverting them to experimental armored gliders would demand strategic justification that the A-40 could not yet provide. Even if towing power improved, landing constraints persisted. Fields near front lines were uneven, cratered, often under observation. A gliding tank required space and relative concealment. Its arrival, though silent after release, depended on a noisy tow approach detectable by enemy scouts or radar. Every advantage carried exposure. Physics does not negotiate with optimism. It rewards balance and punishes excess mass. The A-40 succeeded once because conditions were carefully controlled and duration limited. Stretch those variables under wartime unpredictability, and margins evaporate. Yet within those margins lies something remarkable. Engineers calculated, modified, tested, and achieved lift from an object never intended to leave Earth. They forced an armored chassis into aerodynamic compliance. It was not impossible. It was improbable. And improbability in war must justify itself repeatedly. The A-40 could not. But its brief ascent remains a case study in boundary testing, where ambition meets airflow and survival depends on numbers as much as courage. By 1944, the Eastern Front had transformed. The Red Army advanced westward in massive formations, artillery rolling like thunder across Belarus and into Poland. Airborne operations continued, but they were no longer the fragile gambles of 1942. They were integrated into broader offensives supported by overwhelming force. The A-40 belonged to an earlier, darker chapter. Yet across the world, other nations wrestle with similar questions. How do you deliver heavy equipment rapidly across contested ground? How do you combine mobility and protection in a single decisive stroke? Germany experimented with massive gliders, such as the Messerschmitt Me 321 Gigant, capable of transporting vehicles and artillery. The Allies developed the airspeed Horsa and the American Waco CG, for the land troops and light equipment during operations like Normandy. None attempted to bolt wings directly onto a tank. Instead, they carried vehicles inside cavernous fuselages. The Soviet attempt had been uniquely direct. Instead of building a larger aircraft around a vehicle, they tried to transform the vehicle itself into the aircraft. It was an inversion of conventional thinking, and it reflected circumstance. Soviet industry in 1942 lacked surplus heavy transport aircraft. Building enormous cargo gliders was resource-intensive. Modifying existing light tanks seemed, at least initially, more efficient. Use what you have. Adapt Improvise. In that sense, the A-40 shared DNA with countless wartime innovations born of constraint, field modifications, improvised armor plating, makeshift repairs under fire. The difference was scale. This improvisation aimed at the sky. By late war, as technology matured, airborne doctrine evolved toward practicality. Tanks were airlifted decades later by large cargo planes, such as the Antonov A-12 and eventually the colossal N-124. Parachute delivery systems improved, but these advancements relied on engines, materials, and structural engineering far beyond what existed in 1942. The A-40 was ahead of its time and ambition, but limited by its time and capability. There is also a psychological dimension. In the bleak months after the German invasion, the Soviet Union needed symbols of ingenuity. Projects like the flying tank demonstrated that innovation continued despite encirclement and loss. Even if impractical, they signaled resilience. Morale matters. When engineers and soldiers believe limits can be challenged, they endure hardship differently. The A-40 flight, witnessed by ground crews and aviation staff, proved that creativity had not been extinguished by retreat. Still, war rewards results. By 1945, Berlin lay in ruins under Soviet artillery. Victory came not from airborne armored gambits, but from relentless production and coordinated offensives. The T-34, not the T-60 glider, became the icon of armored warfare. The IL-2, not the TB, three-tow plane, symbolized air-ground integration. The flying tank receded into obscurity. Yet historians who revisit the project often pause at its audacity. They study photographs, analyze performance estimates, debate whether a more powerful tug might have changed its fate. They imagine alternate scenarios in which specialized towing aircraft escorted by fighters deliver armored gliders behind enemy lines during a pivotal battle. Such speculation is inevitable, but history unfolded along a different path. The A-40 remained a prototype, a singular experiment that tested both engineering theory and human nerve. Its legacy is not measured in battles won or territory seized. It is measured in the willingness to attempt what others dismiss as fantasy. And perhaps that is enough, because in war, innovation is rarely linear. It branches, fails, adapts, and occasionally succeeds beyond expectation. The flying tank did not reshape strategy, but it expanded imagination. It reminded planners that even the heaviest machines could be reconsidered. For one flight over Ramenskoye, armor met air, steel left soil, and the boundary between the possible and the improbable shifted, if only slightly.